So the thing about switching things on and off, and the thing about digital electronics is that you can turn things on and off. But what if you want something in between, some kind of value in between? Right now, all you can do is push 5 volts through your circuit or 0 volts. That's not really interesting. You know, we want to make the LED, a little bit brighter, a little bit dimmer. How do we do that? So let's start off by just graphing what we have right now. So let's graph voltage against time coming out through pin 13. Okay, so time. So this is 5 volts, let's say, and then this is 0 volts on our y-axis. So this is 1 second, 2 seconds, 3 seconds, and 4 seconds, right? So it's at 5 volts for 1 second, and then 0 volts for another second, and then 5 volts, and then 0 volts. And this is what's called a square wave. Well, it's not really square here. Actually, let's make it square. Okay, that's more square, not really square. But anyways, it's a square wave, which just means it's a wave that looks square. So you're going at 5 volts, 0 volt, 5 volt, 0 volt. And that's corresponding to the LED being turned on, turned off, turned on, turned off, right? So the Arduino can't really do anything that's like at, 2.5 volts in between. It can't make this level, it can't push out 2.5 volts of potential. So what we can do instead, and this is what pulse width modulation is. It's a very fancy name, but don't worry about it. It's actually very simple. Instead of pushing out 2.5 volts or 3 volts or whatever in between, we can pretend. This is a form of cheating. We can make it almost as if we were pushing out 2.5 volts by doing something called pulse width modulation. So what that is you can see here that the square wave that we had before, it was pretty evenly spaced, right? But what if we did this? What if we did, instead of every second, let's say every half second, right? We do 5 volts for half second, and then we just wait a whole second, and then 5 volts for another half second, and then wait a whole second, another 5 volts for half second, right? So this is different from before. You're only turning it on for a smaller length of time. What that means is, so this is at 0.5 seconds and 1 second. To you, it'll just look like the LED is turning on and off at a different rate. But if you do this fast enough, say basically between 10 milliseconds or 20 milliseconds, what this will do is that it'll flick the LED on and off really quickly. Too fast for your eye to really comprehend, but since it's off for a longer amount of time compared to when it's on, it'll look dimmer actually, and we'll see that very soon. Conversely, what we can do is make this a little bit longer, and so maybe 2/3 of the time it's on, and then 1/3 of the time it's off. 2/3 of the time on, 1/3 of the time it's off, and that's closer to 5 volts. So here you have very little time spent being off and more time spent being on. So the width of the pulse is what's being modulated. You're just changing the width of the pulse, and if you do it fast enough, it's just tricking the human eye into thinking that it's actually dimmer or brighter. So the maximum you can go to is 5 volts again, or pretending it's 5 volts, and the lowest you can go is just turning it off all the time, which is 0 volts. So you're never actually pushing out anything different from 0 volts or 5 volts. By changing the rate at which you push it out, the amount of time spent being on compared to the amount of time being spent off changes. And that's what will make the LED look like it's going brighter or dimmer. And this doesn't just apply to LEDs, it applies to other things that you can drive with it, like a motor. So you could turn the motor on, all the way and just make it go full speed, or you could turn it on in little pulses that are a bit spaced apart. So, it's never getting driven at anything different from 5 volts or 0 volts, but to you it'll seem like it's going slower. So it's just a little trick that we can do, and there's actually a function in the Arduino code that we can use for this that you'll see in the code below. It's called, instead of digital write, which we're using for the LED, we're going to use analog write. Yeah. So we'll talk about this function in the code. Yeah. Is it filming? Yeah. So you should have already opened up this program called Fade under File, Examples, Basics, Fade. So if you look at the code, it'll say the LED pin is 9. So let's move this over to pin 9.
And by this, he means the positive end.
Yes, let's move the positive end of the LED over to pin 9. So, we haven't loaded the program yet, so it's off. And what it will do is, oh shit, this is not the program we want. Yeah, we'll cut that part out. We'll actually write this program. Yeah. All right, start over. Okay, so if you actually wrote the code that we had for you up above, so right now the LED is still blinking on and off, but what we're going to do now is actually make it, fade and go from, off to on, but go to all the levels in between, and then, on back to off. So the first thing you do is obviously you set your pin mode to output, and as outlined in the text, this basically says you're going to be outputting on pin 13 as opposed to inputting, right? And the next thing you want to do is in your code, do this whole little for loop. So if you've taken programming before, what you do is, then this is easy. But if you haven't, what it does is it just goes through different values. So in the code it says for int I equals 0, I less than 255, I plus plus. That we're just going to write this value I over pin 13. So pin 13, analog write 13, and just give it I. And so why do we go from 0 to 255? So this is just a little bit of background. 255 is the maximum value that you can represent with 8 bits. So we'll go over bits later. And it just means that 255 is the maximum value and 0 is the lowest value that you can represent with the PWM. So we go from 0 to 255, and let's go all the way back down. So for int I equals 0, I equals 255, sorry. I larger than equal to 0. I minus minus. You do analog write again. 13I. So that will basically.
You want a delay in between.
Oh yeah, and in between, after each analog write, we always do a delay, just of say 10 milliseconds, right? And that'll basically just make it slow enough that we can actually see things happening. If we just did it without delay, it'd be so fast that we couldn't even notice what was happening. So now you have these two for loops writing out the values between 0 and 255, up and then back down. And with a delay of 10 milliseconds between each value, so we can actually see it happening. And just load this program, and we'll see what happens. Oh, sorry.
There. So now you can see that the LED is slowly getting bright. Now it's slowly getting dim.
Mm-hmm. And it's going down. Okay, so now it's bouncing back up, and then it's going back down.
Going back down.
So this is PWM in action. For each one, whenever we set it to a certain value between 0 and 255, that just sets the width of the pulse. That just sets how long each pulse of on goes for, relative to the pulse of off. And that'll just, to our eyes, it'll just look like the LED is brighter or dimmer. But what's actually happening is just getting turned on and off really quickly. So that's a neat little trick, and that's very useful whenever you're dealing with circuits with the Arduino. Yep. So now we're going to move on to the next part, which is dealing with sensors using the photo cell.